Hi, my name is Dr. Ahmath. In this video lecture, we are going to talk about the parametric curves. And one of the examples of the parametric curves is the line segment. So essentially, the line segment is the portion of the line between the 2 points. So let's review what is the line between through the 2 points and how to construct the line. So in order to try to understand its difference from a line segment. So let's say you are given 2 points, so with the coordinates x0, y0, and x1 and y1, and the rectangular coordinate system. Then we can just make a line which is going to passing through these 2 points, and the general equation of this line is going to be always kx is equal to the b. So essentially, the k is going to be the slope of this line. So it controls the rotation of this line, right? So how much it is rotated. And the b is going to be, is called the y-intercept. It's essentially is going to tell us at which point, so this line is going to pass through the y-axis. So here, this point is going to be equal to the y, where is going to be equal to the b, sorry. So let's say we are given an example. So we're given 2 points, and I would like to construct the equation of a line. So in order to do this, I just need to plug the coordinates of the 2 points into these two formulas and find the k and b of this line. So let's do this. So in order to calculate the k, the slope of this line, I need to subtract the y coordinates of these 2 points. So let's say the q is going to be the second point, and if I subtract this 1, the y coordinate of the p, from the 3, it's going to be equal to the 2. So essentially 3 minus 1 divided 2, now the subtraction of the x coordinates. So I need to subtract 2 minus 3, it's going to be equal to the 5, which is going to be equal to the 0.4. So now we need to calculate the b, essentially the y-intercept, using this formula. So please note that x0 and y0 are the coordinates of one of the points on this line. So it doesn't really matter whether this is the first point or the second point. For example, we can just put the first point. It's going to be b is equal to 1, the y coordinate of this point here, right? Minus 0.4, the k which we have just calculated, times to this minus 3, which is the x coordinate of this point. So minus 3. So please note that minus 3 times the 0.4 with a negative sign is going to be equal to the plus 1.1. So if you add this to the 1, it's going to be plus 2.2. So essentially, the equation of this line is going to be equal to the 0.4 plus 2.2. So what does it give us, this equation? So all the time we've been talking about the equation of the lines or the curves. It is really important for us to know the equation because it tells you the coordinates of the points along this curve. So you need to understand the equation of a curve as a map of this line. So it tells you, hey, how to reach a certain point on this line. For example, if I would like to know the coordinates of the point at the x is equal to the 4, for example, here. So I would like to know what are the coordinates of this point, okay, where x is equal to the 4. X is equal to the 4. So what I'm going to do is I'm just going to substitute this to the equation of a line and calculate the y. This is going to be equal to the 0.4 times to the 4 plus 2.2, which is going to be equal to the 1.6 plus 2.2, which is 3.8, right? So the coordinates of this point is going to be equal to the 4 and 3.8. Okay, so essentially this equation is going to tell you the coordinates of the point along this line. So now, um, so what is a line segment? Is just the portion of that line. So you see, so the line is passing through these 2 points. It started a way below the first point and it continues a way behind the second point. But the line segment is exactly the portion between these 2 points. Okay, so we need to now figure out an equation of this line segment which is not going to go out from these 2 points. Okay, so no matter what parameter you put into that equation, it is going to give you always the point between these 2 points. Okay, so it appears we can define this equation in this form. So essentially, the coordinates of the starting point times to the 1 minus t plus the coordinates of the ending point times to the t. So where we are going to call the t as the parameter, and you see that t is always changing between 0 and 1. So this we call as an equation of a line segment. And now, if you remember previously, if you're given the equation of a line, you just need to choose the value of the x, okay? Then you substitute this to the equation and find a y, right? While here, you need to change the t. For example, t to be equal to the 0, or t to be equal to the 0.5, t to be equal to the 1 is going to give you the points at a certain distance from the starting point. But all the points is going to be in between these 2 points. So for example, if the value of the t, let's consider an example. So let's say we're given 2 points, minus 3, 1, 2, and 3. So first of all, I need to construct the equation of the line segment in between these 2 points, right? So I'm going to write down the starting point. Sorry. So the starting point is going to be minus 3 and 1 times to the 1 minus t plus the ending point here is going to be 2 and 3 times to the t. Well, this is an equation of a line segment. And now the only thing which I need to change is the value of the t. So for example, if you would just substitute t to be equal to the 1 to here and to here, so what would you get? So essentially, if you substitute the t to be equal to the 1 to here, that point is going to be simply 0, right? And what you get is simply 2 and 3, right? So if the t is equal to the 1, then you will get 2 and 3. So now let's just change the values of the t. For example, if the t is equal to the 0, what kind of point do you get? So essentially the starting point. So let me write down the equation of the line segment here one more time. Minus 3 and 1 times to the 1 minus t plus 2, 3 times to the t. Well, if the t would be equal to the 0, so this is 0 here, and this is 0, then this bracket would be equal to the 1, and this point is going to be just neglect because of that 0, right? What you get is just the starting point, okay? So just changing the value of the t is going to give you always the points between these 2 points. So essentially, if the t is equal to the 1.5, then the coordinates, so it's going to give you the midpoint between these 2 points. So exactly in the middle between these 2 points. So we can try to calculate this for this example. So let's say, again, the equation of a line segment between these 2 points are minus 3, 1 times to the 1 minus t, right? Plus 2 and 3 times to the t. So I'm going to substitute 1 over 2 in both of the parts of this equation. And this is going to be minus 3 and 1 times to the 1 over 2 plus 2 and 3 times to the 1 over 2. If you just calculate and simplify the terms, it is going to be minus 3 over 2 plus 1, it's going to be minus 1 over 2, right? And 1 over 2 plus 3 over 2 is going to be simply equal to the 2, okay? The coordinates of this point here is going to be minus 1 over 2 and 2. Okay, so this is how we're going to calculate this. So by just substituting the value of the t, we can just find the points. Okay, so in this sense, it is really important now for us to understand what makes the difference between the line through the 2 points and the line segment between the 2 points. Again, so the line has no borders essentially. So it goes away behind the ending point and before it starts away before the starting point. So it doesn't have really length. We can't just tell like, hey, so tell me the length of the line or half a length of the line, or and also it doesn't have a direction. So it doesn't matter from which point you're taking the first point and the second point. For all of the problems conducted with an equation of the lines or the lines, it doesn't matter which point is the starting point or the ending point. Well, all of these things are different for the line segment. For the line segment, so the portion of the line between these 2 points is defined. So we can't really define the infinitely long line. I mean, unless your points are really far away from each other. So this is going to be just a portion of the line between these 2 points. So for the line segment, we have the direction. So it depends which point you're choosing, the first, the starting, and the ending point. You may calculate the points, the problems differently. So again, there is starting point, there is ending point. There are borders. The starting point and the ending points are the borders of the line segment. And also now we have the length. So the length of a line segment is going to be the distance between the 2 points, We can calculate, for example, midpoint or the point which is three-quarter distance from the three-quarter distance from the origin, from the starting point, and so on. So the three properties make the difference between the lines and the line segments. So I hope that you understand what is the difference between the line and line segment. So now what we're going to discuss is something which is called a bisector. So it's a line which is going to split the line segment into the two parts. But before we do that, so let's consider one more example of finding a point on the line segment. For example, so let's say you are given 2 points. You need to find a point on the 3/4 of the way from the P to the Q. So what does it mean? So I need to just trace this point starting from the P along this line, okay, and just stop in a place where the length of this of this trace is going to be exactly 3/4 of the of the length of the line segment. Okay, so in order to calculate this point, the coordinates of this red point, what you have to do is you just need to substitute the value for the t to be equal to the 3/4, and that's it, into the equation of a line segment. So let's calculate this. So let's say we're given the 2 points. It's going to be -3 and 1 times the 1 minus. So now I'm just going to substitute the value of the t. Right, immediately it's going to be 3/4 plus the second point, it's 2 and 3 times the 3/4. Okay, the rest is the simple calculation. So please note that the points are given using the two tuples, so essentially the two numbers which are written inside the brackets. And you can't really change the orders, right? If you're adding the 2 points, you need to add the corresponding positions correspondingly. So essentially the first position of the first point is going to be added with the first position of the second point. So now I'm going to multiply. This is 1 minus 3/4 is 1/4. So 1/4 times the -3, it's going to be -3/4 plus 6/4, right? Okay, so now I'm going to multiply 1 to the 1/4. It's going to be 1/4 plus 9/4. If you simplify everything out, what you get is here is 3/4 and 10/4. So essentially, the coordinates of this point here is going to be 3/4 and 10/4. So you can find the point at any distance between these 2 points by just playing with the t. So if you would like to find, for example, the point on the 1/6 of the way between P and Q, then just substitute t to be equal to the 1/6, and that's it. So now let's talk about the bisector. So let's say you are given again a line segment. So a line which splits this line segment exactly at in the middle point is going to be called as a bisector. So please note that you can just create lots of many bisectors by just like changing the angle of those lines. You can create infinitely many bisectors. So sometimes we need the bisector which is perpendicular to this line segment. And let's solve a problem where we need to create an equation of such a line. So let's say we are given 2 points with the coordinates -3 and 2, and 5 and 4. What I have to do is I need to find the equation of this bisector, which is perpendicular to my line segment. Okay, and again, the general equation of this line is going to be in the form of kx is equal to the b. So this is what we've considered in the beginning of the lecture, right? So in the beginning we said, hey, so we can construct the lines using this equation. So now the problem is, so I'm given the point on this line, just one point, right? This red point. So let's first of all find the coordinates of this point. So in order to do this, if you remember, you need to multiply -3/2 to the 1/2 plus 5 and 4 times the 1/2. If you calculate it, it's going to be -3 plus 5. It's going to be 2/2. It's going to be 1 simply. And the second point is going to be 1. 2 times the 1/2 is 1. Plus 2 is going to be equal to the 3. So the coordinates of this point here is 1 and 3. Okay, so I'm just going to delete all of these things because I need the space, sorry. Okay, the coordinates of this point is going to be equal to the adding these two coordinates, x coordinates and the y coordinates, and dividing them to the 2. So I can just calculate this here as the 1, and this is going to be equal to the 2. So, but just one point is not enough for us to calculate the equation of a line. So we need to know some other attributes of this line. So another information which we know is that this line, the white line, is perpendicular to the line segment. Okay, so what does it mean? It means that if I would just make a line passing through these 2 points with the equation k1x plus b1, so essentially, so the slope of this line is going to be equal to the k1, and the y-intercept is going to be equal to the b1. And if I'm given the equation of a line, of the white line, as a kx plus b, and if they are perpendicular, then the multiplication of their slopes is equal to the minus 1. So essentially, if I just get this k1 and multiply this as a k, it's going to be equal to the 1. So now the idea is I'm going to find this k here by just finding the k1. So we can find a k1 because we know the coordinates of these 2 points here and here. So essentially, we can subtract the y coordinates of these 2 points and divide them to the subtraction difference of their x coordinates. So the k1 is going to be equal to 4 minus 2 divided to the 5 minus 3. So this is going to be equal to the 2 divided to the 8, right? Which is going to be equal to the 1 over 4. Okay? I'm going to just substitute this to here so in order to find the k. So k is going to be equal to the minus 4, right? Because if you multiply 1 over 4 to the minus 4, you will get minus 1, essentially. So now I know the slope of this line. I can find the equation of the b, the y-intercept, right? By just using that formula. So the y1 minus kx1, where y1 and x1 are going to be the coordinates of a point on that line, right? So we know one point on that line. So I'm just going to substitute this there. So it's going to be 2 minus k, which is going to be plus 4, times the 1, which is going to be equal to the 6. So you see, so the equation of this line is going to be equal to the y is equal to the minus 4x plus 6. Okay? So this is how, for example, we can find the equation of a bisector, which is perpendicular to our line segment. So I hope that this lecture was useful for you. So in our next video lectures, we're going to talk about the other parametric equations. So I hope that you've got this idea of the parameter on the equations. Thank you very much for your attention.